This is our Chapter 17 lecture on alcohols and phenols. We've already seen quite a bit of alcohols, and we've seen some phenols in the aromatic chapters, but in this chapter we're just going to make sure we're all set on their properties, on the reactions used to make them, as well as the reactions that they undergo. So let's just get our terminology straight here. An alcohol has an OH group bonded to an sp3 carbon, so a saturated compound with carbon single bonds directly attached to the OH-bearing carbon. A phenol has an OH group bonded to an aromatic ring. Be careful with your terminology. Phenol is different from phenyl, P-H-E-N-Y-L. The phenyl is just the aromatic group. Phenol is an alcohol attached to an aromatic group. An enol is an unstable compound for the most part. It has an OH group bonded to a non-aromatic sp2 carbon. Aromatic sp2 carbons are excluded because there's extra stability that comes from it being aromatic, but normally an OH will not be attached to an sp2 carbon, so OHs will typically not be bonded to double bonded carbons. Phenol itself refers both to that aromatic compound, so hydroxybenzene, its common name is phenol. Phenol is acceptable as an IUPAC name. Phenols are a class of compounds, so anything that has an OH group attached to an aromatic ring is considered a phenol. So methyl salicylate here, for instance, it has the OH group, but it also has this ester group over on the side. It is a phenol. But phenol itself is hydroxybenzene. The book mentions these urushiol. They're common compounds that give poison ivy their certain effect, and this is actually a common feature that comes up in a lot of biological systems. A 1,2-dihydroxybenzene is known as a catechol. So if I draw a benzene ring with two hydroxyl groups next to each other, that is catechol, C-A-T-E-C-H-O-L. So as we have already seen, and we'll see further in this chapter, the OH group itself is one of the most important functional groups in organic molecules, especially biological molecules. The OH group is typically key to functionality of many important molecules. So let's just very quickly review the nomenclature of alcohols. Please, on your own, do the nomenclature worksheet, so you get practice on naming alcohols as well as the carbonyl compounds, which we'll be studying coming up. First of all, let's classify alcohols by the number of R groups that are attached to the OH-bearing carbon. So here's C with the OH. We're looking at how many R groups are attached to that C. So just one R group is primary, 2 R groups is a secondary alcohol, 3 alkyl groups is a tertiary alcohol. So whether an alcohol is primary, secondary, or tertiary will define its reactions and its properties. We're going to follow the normal IUPAC naming rules. We're going to find the longest carbon chain closer to the functionality of the molecule, ending it with OL. We use OL, but we'll drop the final vowel of the parent compound. So methane becomes methanol, pentane becomes pentanol, and that's just to avoid a EO double vowel combination, right? So a 5-carbon chain with a methyl and an OH on carbon 2 is 2-methyl 2-pentanol. Don't forget rings. You can do relative stereochemistry with cis or trans. So cis-1,4-cyclohexene diol. If there are 2 hydroxyl groups, we'll call it a 1,4-diol or a 1,2,3-triol, for instance. The OH group will typically have precedence over a lot of the other functional groups that we've seen so far. So we'll number from the side that's closer to the OH as opposed to closer to a benzene ring or closer to a double bond. The OH has priority over the groups we've studied so far. So this compound here with 4 carbons, a phenyl group on 3, a hydroxyl group on 2. We numbered from the side closer to the hydroxyl group as opposed to the phenyl group. So that's why it's 3-phenyl 2-butanol and not the other way around. Here are a couple of alcohol common names, which you should be aware of. These are acceptable to be used as IUPAC names. So typically when we say IUPAC name, we're talking about a systematic name, but in these specific circumstances and those other circumstances we've seen so far with the aromatic rings like aniline and benzoic acid and things like that, those are accepted by IUPAC. So where phenol had an OH directly on a benzene ring, benzyl alcohol has an OH on a CH2 attached to the benzene ring. So phenyl CH2OH, that's benzyl alcohol. We could call it phenyl methanol because there's the one carbon outside of the ring there. If I have a 3-carbon alkene with an OH on the non-double bonded carbon, that's called allyl alcohol, ALLYL, says the OH is in an allylic position next to but not attached to the double bond, right? So allyl alcohol, here's tert-butyl alcohol. There's the tert-butyl group, sometimes also known as T-butanol. 1,2-ethane-diol is commonly called ethylene glycol, a common ingredient in antifreeze. Here's glycerol, 1,2,3-propane-triol, commonly known as glycerin, but that is not a proper chemical name. Glycerol with the OL ending is the proper chemically formed name. So glycerin can be used as an ingredient on a drug or something like that, or a preparation, but glycerol is the name that we use in chemistry.